Hello and welcome back, Algebra 2. I missed you. So today we're doing factoring. Good news. You're thinking, hey, I already know how to do this. Great. It's been a long time since we've done it though. So this week we're reviewing how to factor because this is probably the most important aspect of all of second semester because you're going to use it again in geometry, algebra 3-4, pre-calculus, calculus, everything. You use factoring a lot. So we want you to be really good at it. And a lot of people, quite honestly, stink at it. So if you don't stink at it, you will be ahead of most people. All right, so here we go. Remember, our first step is to think of this as the first three letters of the alphabet, A, B, and C. Remember, when we do this, we're also taking the sign in front of it. So this would be a positive 2 for A 3 for B, and a negative 20 for C. All right, our first job is to go to our favorite state, California. We're going to do C times A. So in that case, we would have negative 20 times 2. That gives us negative 40. So we write down negative 40. Then we're going to write down all the factors of negative 40. Now, honestly, I already did that step. I just kind of skipped it. So since they have nothing in common, I'm going to do C times A, negative 20 times 2, that gave us negative 40. Then I'm going to start with the number 1, and I'm going to keep dividing negative 40 by each of these numbers. So is it divisible by 2? Yes. Negative 40 divided by 2 gives me 20. And I'm kind of ignoring the negative signs now. We'll fix the signs in a minute. Can I do 40 divided by 3 and get a nice pretty number? No. It is divisible by 4 though, and 5, but not 6 or 7. 8 works. Ooh, look, because I have the 8 there, I like to put this cool little dotted line here, and then I flip all of these backwards. So this one's going to be 10, 4, 22, and 41. Just like that. Now, as far as the signs are concerned, let's talk about the signs. Remember, if we have a negative sign in front, we're going to keep negative signs in the front of all of my column here. So negative sign in front here, we have negatives all the way down the column. If this is positive, remember we make all the bottom ones negative and all the tops would be positive. But for now, this one's negative, so I drop down a negative on all of these. Remember, the reason why is because a negative times a positive gives us a negative. So that's why one of them has to be negative and the other positive. Now I have to figure out which of those will add to positive 3. Now, since this is a positive number, I can completely eliminate the entire bottom. The bottoms will always give me negative answers. The tops will always give me positive answers. If you can't remember that, that's okay. You don't have to eliminate them. This is just a way to, save you half the work. So for me, negative 5 plus 8 seems like a good answer. In fact, there's only one possible answer for each of these problems. So negative 5 plus 8 works. If you think there's more than one answer, well, first of all, you're wrong. You should go back and make sure that you've done your negative positive signs correctly and that you've added or subtracted correctly as well. Okay, so negative 5 and 8 is our magical pair. Now we're going to go back to our equation here, or our expression here. I'm going to go ahead, remember we did C times A, so let's go ahead and do C times A. And you're basically just moving that 2 over here to the negative 20. And we already said that that was negative 40 right there. Okay, now that I've done that, I'm going to set up my parentheses. I always put an x here and an x here if this is just an x squared. And then I'm going to plop down my negative 5 and my positive 8. Okay, and that came from these two here, the pair that I circled. Remember, there's only one pair that works, so you have to use that one. Next, I multiplied A times C earlier, so now I need to divide back that 2. If your fraction reduces, go ahead and reduce it. Does 5 over 2 reduce? No. So I'm going to take that 2 and bring it up. That's why this is called bottoms up. Bring the bottom up to the top. So that becomes 2x minus 5. Over here, does 8 divided by 2 reduce? Yes, it does. So I'm going to go ahead and do 8 divided by 2 is 4. And I'm finished. That is it. If you want to check your answer, you know how to do that. You would just do what we call the box method. Put these in the box, multiply them together, and you would get the first thing that you started with. All right, let's move on to another example. Again, we've got A, B, C. We're going to go California. California is C times A. C is 6, A is 3, so that gives me 18. I'm going to do all the factors of 18, so that's going to give me 1 times 18. I have 2 times 9. 3 by 6 works. 4 does not work. 5 does not work. 6 does. Oh, and look, I've repeated a 6. So as soon as I repeat that number here, I'm just going to copy everything in reverse order. So 9 and 2, 18 and 1. Next, since this was positive, I know that a negative times a negative is a positive, so all the bottoms will be negative. Also, a positive times a positive is a positive, so all the tops are positive. Alright, I'm trying to make them add to negative 11. I said the word negative, so it cannot be any of the top numbers. All of those will add to positives. On the bottom, which one adds to negative 11? Hopefully you chose negative 9 minus 2. So back I go to my expression here. I'm going to go ahead and move that 3 all the way over there to the C to make the California. And we already said that 3 times 6 was 18. That California number always goes on the end. Then I go ahead and make my factors. This was x squared, so this is always going to be x and x. And then the two numbers that I circled there are going to go here. Just like that. Finally, my number that I multiplied was 3, so now I've got to divide it out. So I divide by 3. 9 divided by 3 gives me 3. That does reduce, so I just do that. 2 divided by 3, that does not reduce and it doesn't divide, so I've got to bring that 3 up to the top. And I am finished. Ready for another? Great, let's give it a try. Now, a few of you recognize patterns, and you may recognize that this is going to give us a special answer. Don't tell anyone, just leave it as a secret. So 16 times 9, that's going to give me 144. This is going to be a big old list. That's alright, I can do it. Again, if you start with 1 and you go in order, it's going to make your life so much easier. You won't accidentally miss one that's important, and it just makes it so you don't have to think as much. So I'm going to divide this by 2. Is it divisible by 3? Well, I don't know. So I take out my calculator, or I could actually do my little trick that I showed you. 1 plus 4 plus 4 is 9, which is divisible by 3, so I know that this is divisible by 3, and that in fact gives me 48. Is it divisible by 4? Yes, because I could take 2's answer and cut it in half. 5? No. Is it divisible by 6? Yes, because 2 and 3 both work. That gives me 24. Is 144 divisible by 7? No. 8? Yes, because I could cut 4's answer in half. That gives me 18. 9? Does 9 work? Oh yeah. 10? No. 11? No. 12? Yes. Ooh, I have the same answer twice. So now I'm going to recopy everything the exact same way, but backwards. 24 and 6, 36 and 4, 48 and 3, 72 and 2, and 144 and 1. Now, because this is a positive number up there, I'm going to leave everything on top positive. Everything on bottom is going to be negative, though, because a negative times a negative is what I need to give me that positive answer of 144. Next, this is a negative 24, so look at all of these I can eliminate. It's not any of those on top. It has to be one of these on the bottom. So I look through my list, and look, the very first one I come to is my answer. Negative 12 minus 12 gives me negative 24. So back we go. We're going to put this in factored form. Oop, before we do, though, I almost forgot. Let's multiply our a by our c. So 16 times 9 we already said was 144. That's our California number. Then I'm going to go ahead and factor this. This is x, and negative 12 and negative 12 are my two answers. My a was 16, so that's why I have to divide by. Look, everything seems to be all matchy-matchy here. That's nice. So 12 over 16, that gives me 3/4. And this is the exact same thing as that. So if I wanted to, I could write squared, but just so I don't confuse anyone, I'm going to continue to write it out. Now, can I stop right there? No, because I still have a denominator. So I have to bring that bottom up to the top. That gives me 4x minus 3. And this one, not so coincidentally, since it was exactly the same, also gives me 4x minus 3. So that would be one way to write the answer. Another way to write the answer is, if you don't like writing it twice and you want to save yourself some writing, you can just write it once and put a little squared up there. Either of these would be considered the correct answer. Alright, so this was a perfect square. Now let's go on to another special case. Here I have 36x squared minus 25. I appear to be missing something. Now remember, our magic trick here was I could go ahead and multiply 36 by 25, but that's going to be an enormous number, and my chart here is going to be so long that I'll go off the screen. We don't want that. So instead, since these are two numbers that are both perfect squares, and there's no b term, there's nothing with an x, I'm just going to square root each of these in my head, or maybe on the calculator. Remember, when this happens, I'm going to have a good twin and an evil twin, like me and Mr. Shackelford. So for the good twin, I'm going to do 36 square rooted is 6. Square root of x squared is x. 25 square rooted is 5. Now I'm going to place those exact same things over here for my evil twin, Mr. Shack. And then I'm finished. That's it. If I really wanted to check it, I could of course multiply this out, and my middle terms, my x's, would all cancel, giving me this original answer that I started with. Alright, if you feel like you could do this on your own, that's great, but there appears to be something that's going to be very difficult about this one. 24 times 64. That's an enormous number. Our list, again, would go on forever. Well, we probably don't want that, but they appear to have something in common. So now we need to take out what they have in common. That means we're going to have to do the GCF like we used to do way back in last week's lesson. So let's do a little factor tree for 24 and 16 and 64. Alright, 24 is 6 by 4, which is 2, 3, 2, 2. 16 is 4 by 4, which is 2 by 2 by 2 by 2. 64 is 8 by 8, which is 2 by 2 by 2, twice. Alright, now to find the GCF, all I'm going to do is circle whatever they have in common. So right here, I have a 2, a 2, and a 2. I'm going to write that down once right here. They have another 2, 2, 2. I'm going to write that down again. They have yet another 2, 2, and 2. So I write that down again. And that one has a 2, that one has a 2, but this one does not. That has a 3, but those do not. So I'm finished with my GCF. They don't have any letters or variables in common because this one has no letter or variable next to it. Therefore, 8 is my GCF. So here we go. I'm going to take each of these and divide them by 8. So I put that 8 on the outside, put my big old set of parentheses. Then I'm going to go ahead and divide. This one gives me 3. And remember, we do the big numbers, bases first, and then we'll go back and do the exponents with the variables. So I've got 16, negative 16 divided by 8 is negative 2. Negative 64 divided by 8 is negative 8. Go back and do the variables. There's no variable to divide by, so that makes this one kind of easy. I can just copy the variable with its exponent. And that one didn't have one. Okay, well, I'm finished with factoring out the GCF. Now it's looking like my California is going to be easier. I can do California is negative 8 times 3. Negative 8 times 3 gives me negative 24. A much easier number to work with than, let's see, what was 24 times 64? 1536 would have been my number if I had worked with 64 and 24, and that seems a little too big. So 24 is 1 by 24, 2 works, 3 works, 4 works, 5 does not, 6 does, and look, I've copied my 6 down again, so I put that cool dotted line there, and then copy everything down. Since the first term thing here was negative, I'm going to put negatives on my first term all the way down, because a negative times a positive will give me that negative answer. Now I'm trying to figure out which of these will add to negative 2. Since this is the negative number, I can cancel out the entire top. It could not possibly be any of those, because all of those would be positive answers. Which of these gives me an answer of negative 2? Well, the first one, negative 6 and 4. So I circle that. That's going to be my magic pair that I'm going to use. This 8 just gets copied down. There's nothing to do with him. I'm going to move my a over here to make California. So this gives me x squared minus 2x minus 24. That's that same negative 24 that we had there, because we did 3 times a negative 8. Next, I'm going to go ahead and factor it. Again, that 8, we're just copying him down. We're completely ignoring the 8 for now. X squared is going to be x, and then these magic numbers that you circled here, our spectacular pair, is minus 6 and positive 4. Finally, we multiplied by 3, so now we have to divide by that 3. We're going to reduce any fraction that we can. If not, we'll bring the bottoms up. So in this case, I've got 6 divided by 3 is 2. Here we're going to bring the 3 up because 4 divided by 3 does not cancel. So that gives us 3x plus 4. And I'm finished. It is completely factored. Again, if I wanted to check my answer, I could go ahead, multiply these two together by what most people know it as FOIL. Our group knows it as the box. And then multiply that all by 8. Let's try another just like it. So when you get enormous numbers to factor, that tells you that probably they all had something in common, and you could have made your life easier by factoring out whatever that was. We're going to do that from the very beginning. So we've got 4, 12, and 216. 216 looks like it's going to be our hardest one. Alright, 4, that one's easy. We got 2 by 2. 12, that one's easy. I've got 4 by 3, which is 2, 2, 3. 216. Now that one's kind of a tough one. I see 2 plus 1 plus 6 is 9. So I know that this is divisible by 9. So let's go ahead and divide it by 9. My calculator says that's 24. So I've got 9 by 24. Now these are much easier numbers to work with. Instead of continuing to divide by 2 and making this tree really long, I used my cool division tricks to help me come up 3, 3, 2, 2, because 4 is 2 times 2, and 6 is 2 times 3. Now let's go ahead and see what we have in common. That one's got a 2, and a 2 here, and a 2 here. So that's a 2. This one's got a 2, and that one does, and so does that one. So another 2. And so 4 is going to be my GCF. They couldn't possibly have anything more in common because there's no numbers left on this one. So I'm going to divide all of these things by 4. Now, when I said that 4 was the GCF, I was only telling you part of the story. We remember from before that we're going to look at each variable's smallest exponent. So in this case, x's smallest exponent was 2. Therefore, I need to stick a 4x squared right there. So that's what I have to divide by, 4x squared. That number, of course, goes on the outside. Now we divide. 4 divided by 4 is 1. 12 divided by 4 is 3. 216 divided by 4, well, maybe I need the calculator for that. That's going to be 54. Another way I could have done it, instead of just dividing on the calculator, is you look at whatever you did not circle on the bottom line of your factor tree. 3 times 3, which is 9. 2 by 3, which is 6. 9 by 6 is 54. That's another way you could do it. Now let's work with our x's. Our variables here, 4 minus 2 gives me 2. Sorry, I'm allergic to exponents. Alright, 3 minus 2 gives me 1, and 2 minus 2 gives me 0 because the x's cancel. Now it looks like I am ready to go. Now I'm ready for my California, and look, as luck would have it, this is a 1, so that makes life easy. 1 times negative 54 is still negative 54, so that won't change. I'm going to copy down my 4x squared. And now, since I don't have to change it, because 1 times negative 54 was negative 54, it doesn't change at all, I know that this is an x and this is an x. Finally, I've got to take my California numbers, which I haven't done yet. So 1 times negative 54 is going to go here. So my California number, negative 54. I start with 1. Yeah, that works. Does 2 work? Oh yeah. How about a 3? Definitely. So I do, in case you don't know, you just do 54 divided by 3 in the calculator. That'll give you 18. Will 4 work? No, because that's odd. Will 5 work? No, because it doesn't end in a 5 or 0. 6? Yes, 6 definitely works because I have a 2 and a 3 there. So I take 3's answer and divide it by 2. That gives me 9. Does 7 work? No. 8? No. 9? Yes. And look, I had a 9 right there. So I put my cool little line and then copy everything backwards. Since this is negative in the front, I'm going to put a negative down the whole front. Now, I'm trying to make them add to negative 3. Since I said negative, I'm going to cross out the whole top. The tops give you only positive answers. The bottoms will only give you negative answers when we add. And sure enough, the very first one gives us negative 3. Wow, we have been lucky recently with all of these first ones working out. That's only a coincidence. I don't know how I did that. So negative 9 and positive 6 go here. Now, normally we would divide right now, but since I multiplied by 1, I can divide by 1 here. I'll go ahead and show it just so you don't forget it in the next example. When I divide by 1, I got the exact same answer. 9 divided by 1 is 9. 6 divided by 1 is 6. So I am finished with the 2. That is my final answer. Sadly, that's all the time we have for today. So I'd like to thank you again for joining us. If you have any questions, go ahead, send me that email. You know that my email is at the bottom of the Canvas page. You know that all of the assignments are on the Canvas page. Please go check it out. I hope you have a wonderful day. Oh, don't forget my office hours. Those are also on the Canvas page. You can chat with me anytime that it says that I'm available. I am more than happy to help you. I hope you all have a wonderful day. Enjoy your math.